How to handle this deadlock situation? Deadlock handling, three types are there. One is prevention and avoidance. Second one is detect and recovery. Third one is ignore. Okay. First, prevention and avoidance. Second one, detect and recovery. Third one, ignore. Ignore means what? Pretend that there is no deadlock. That's all. What normally operating system used to do. Okay. What is prevention or avoidance? Ensures system will never enter into deadlock. Okay, we are having some algorithm. By using that algorithm, we are ensuring that the system will never enter into a deadlock state. Okay, what is detection and the recovery? After the occurrence of deadlock, so we are taking some steps even though the system enters into a deadlock. Now what we have to do? What is the reason of deadlock detection? Okay, we have to find out what is the reason of deadlock detection, and we have to take some steps to recover from the deadlock. That is recovery. Okay, first one, prevention and avoidance means before happening. We are trying to ensure that system is not entering into deadlock. But the detection and recovery means what? After occurrence of deadlock, we are finding the reason and we are trying to eliminate that reason. Third one, ignore, just ignore that there is no deadlock. By system itself will have to recover, or simply we are having reset button. Okay, pressing reset means everything will be reset. Okay, so one more fine-tuned definition for prevention and avoidance. Okay, prevention means ensure that at least any one of the condition does not hold. So what is the definition of deadlock? All four conditions exist simultaneously. What is prevention? Ensure that at least one of the condition does not hold. We are trying to eliminate any one condition. Okay, we are trying to eliminate any one condition. If we are success in that, then we can ensure the system will not enter into deadlock. What is avoidance? Keep the system always in safe state. Later we will see what is safe state and all. This is for your introduction only. Okay. Quickly we will go to prevention. Deadlock prevention. What is the definition? Ensure that at least any one of the condition does not to hold. Okay, does not hold. What is first condition? Mutual exclusion. So out of three conditions, this condition we cannot break. What is our intention? We are trying to break any one condition, but this condition cannot be break. Mutual exclusion condition cannot be break. Okay. What is next condition? Hold and wait. Okay. How can we break the condition? Instead of hold and wait, you just implement hold or wait. Okay, we are just informing the system, or we are just trying to change the condition as hold or wait. That means what? Either you hold the resource or you wait for resource. Don't to do both at same time. Okay, to ensure that, what we have to do? Ensure not requesting any resources when they are holding some. So one condition we are implementing. What condition? We are telling the process, our operating system is telling the process, if you want to, if you are going to request any resource, what is the eligibility? You should not hold any resource. That's all. Okay, operating system will inform the process, if you want any resource, you should not. That means if you are requesting any resource, you should not hold any resource. That is one condition we are trying to make. How it is possible? Okay. Solution. First solution is allocate all resources before the start of execution. Okay. Process P1 needs 5 resources to complete its job. Okay. Process P1 requires 5 resources to complete its job. What we are doing? We are trying all 5 resources is free or not. If it is free, allocate all the 5 resources to the process in the beginning itself. That is before start of the execution, allocate all the 5 resources to the process P1. So what condition will not occur? Wait condition will not occur at any time, because all 5 are allocated to process P1. Okay, so there will never occurs wait condition. It is not going to wait for any resources because all are already allocated. So only hold operation will come, wait operation will never come. So we can eliminate the deadlock. Okay, not eliminate, we can ensure that deadlock will not occur because there is no any waiting condition. Okay, here the problem is poor utilization. That means what? Uh, Suppose process P1 requests 5 resources as I told. Okay, each resources for 1 minute, for example, each resources it requests just for 1 minute, but the process execution time is 1 hour. What will happen? Process execution time is 1 hour, but it requires each resources R1, R2, R3, R4, and R5 for just 1 minute. Okay. So when these 5 resources will be released, after 1 hour only it will be released. So total utilization is 5 minutes, non-utilization is 55 minutes. So many other processes would have wait for all these resources, they may not get the resource. Okay, so because already I have allocated all the 5 resources to the process P1, so it is not able to give another, it is not able to utilize the resources fully. Okay, so if I am asking or if I am allowing resources only at that time, see, fifth minute P1 wants R1. So at that time, if it is requesting R1 and R1 is allocated at fifth second, then R1 can be used by other process also, remaining time. Like that, R2, R3. So whenever required, if you allocate, remaining time, other process can use it. But here you see no other process will use. See, instead of 1 hour, if it takes 5 hours, 4 hours, 55 minutes, these 5 processes will not be allocated to any other process. 5 resources will not be allocated to any other process. That is poor utilization of resources. Okay. Second solution is before a request, release all current resources. That what I told in the beginning. Okay. Before requesting any resource, release all currently holding resources. You can go through the diagram. So what we are telling, this is one request, correct? So before making that request, you have to release a resource R2. Then only you are eligible to make a request. So now it is only requesting, not to holding. Okay, only waiting, not to holding. So any one condition will be eliminated. Okay. Okay, so one example as given data from suppose consider in CD we are having lot of data. For example, 1 TB of data is there. Okay, in CD 1 TB of data is there. This data you have to print using printer. Okay, the process is sort them and print. Three operation. Okay, data is available in hard disk or CD. Our requirement is to print the sorted data. Printing will be done in CPU. Okay. Now we have to transfer all 1 TB data to CPU, correct? We have to transfer all 1 TB data to the CPU. When this data transfer is taken place, printer is not having any work, correct? So it is not requesting printer. It is requesting only CD. CD is allocated. Now printer can be used by any other process. Okay. Once all data is copied to CPU, now sorting to be performed. At the time of sorting, this CD also not required. So that will be released. So now, first condition is it is holding only. Second condition, it is not holding and not waiting because sorting process. 1 TB data was sort பண்றதுக்கு it may take 3 or 4 minutes like that we will just assume. So during that time, CD is also not required. Printer is also not required. Now after sorting, I want to printer, so I am not holding CD. Okay, so that is what I have given here. Before request, you should not hold any resources. If and all you want any particular resource, you release all your currently holding resources. Here, one important problem will occur. For example, process needs 1 hour to complete its work. At 55th minute, it wants one resource. Okay, 55th minute, it wants one resource. So what is the condition? Before requesting how to release all current resources. Okay. I am releasing all current resources what I am holding. I am not holding any resource. Okay. Now I am waiting for another resource. Okay. After 2 minutes, that resource is also allocated. Listen carefully. That resource is allocated. 58th minute, I want one resource that I have released recently. Okay, I'm holding 5 resources. All I have released because I want one new resource. That resource also allocated. After 2 or 3 minutes, 58th minute, I want one resource that I have released recently. Will I get it immediately? No, that can be allocated to some other process. And we cannot give any guarantee that resource will be allocated to this process at some time. That is referred as starvation. Okay, starvation of endless waiting. Starvation indicates endless wait. Okay, so deadlock prevention means we are trying to break any one condition. First condition, it is not possible to break because that is policy decision. Universally, technically or physically, it is not allowed. One resource can be used by one process at a time. That we cannot make as more than one. Okay. Second condition, hold and wait. I am trying to break by using the logic hold or wait. Either you hold or you request. Don't do both at any given time, at same time. By implementing this policy, you can you can ensure that deadlock is not occur or system will not enter into deadlock. First itself, I'm giving the condition. If you want one resource, you resource all the resources you are holding. That is one option. Other option what? If all resources are available, then only you start working. Okay, allocate all the resources you are requesting and then start your work. Deadlock will not occur. Okay.